ladies and gentlemen, once again. On behalf of Safe Trees Society and together with the consortium of the Live TreeCheck project, I would like to welcome you to today's online webinar on TreeCheck Pro software tool and planning of public spaces at times of temperature extremes. Today's speakers are Dr. Ander from Nadace Partnerství, Dr. Kolařík and Mrs. Chalupová from Safe Trees Society. The background for today's online webinar was provided by the Arborist Academy. And now I would like to give the floor to today's first lecturer, Dr. Ander. Unfortunately, he cannot be here with us in person today, so I will now share his pre-taped contribution.
Good morning, everyone. At the starting point of today's webinar, let me briefly introduce the Live TreeCheck project. I would like to put it in the context of the climate situation in the Central Europe, especially in large cities. I will also talk about the reasons why we decided to work on this project 4 years ago, and about all the results we can offer you today. Development of the weather situation in recent years in the Czech Republic, but also in Central Europe, shows that the climate change is here. Heat waves are more frequent than before. The number of tropical days and tropical nights is increasing. Long periods without rain appear more often, causing drought. And when the rain comes, it's much more often in the form of heavy torrential rains, accompanied by very strong windstorms, hail, and similar extreme weather events. This graph can be one of the illustrative examples. The red line shows the increasing number of tropical days in Brno over last 60 years. What was the extreme half a century ago, 20 tropical days a year, is now a common average, while today's extremes are twice as high as 50 years ago. In addition, the effects of heat waves in cities are magnified by the effect of the so-called urban heat island. As a result, the air temperature in the city is 3 to 5 degrees higher than in surrounding countryside. This is caused by large amount of paved surfaces and building materials that absorb solar radiation, turning it to the heat and then radiating it into the public space, which they heat until late at night. Such places can be seen, for example, in this thermal image of the city of Brno. Notice, please, that not only places with large paved surfaces and roofs are overheated, but also the surrounding agricultural land is not covered by the vegetation. The main cause of the urban heat island effect and our inability to resist it is the changed water regime in cities. While in open landscape, 40% of the water evaporates, 50% soaks in, and only 10% of water drains. In the city, the regime is fundamentally changed. Only 30% of the water evaporates back into the air, barely 20% is absorbed, and the entire half of the precipitation drains into sewers and rivers without any use. This water then mixed in urban vegetation, trees, shrubs, plants. They would evaporate it back into the air through the transpiration process and thus cool their surroundings. So we really miss this water in the city. The aim of the Live TreeCheck project is to help cities move from planning phase to the implementation of specific measures, especially blue-green infrastructure. It will help protect people from heat stress and create for them the urban environment that will be pleasant all the year round. As part of the project, we help cities find a way to get adaptation elements into all investment projects. We help change legislation to make it easier to build blue-green infrastructure in the city. And we also help involve local public in the climate change adaptation process. The project consortium consists of 7 Central European institutions, 4 from the Czech Republic and 1 each from Slovakia, Poland and Hungary. We cooperate with 8 pilot cities. We have created consulting systems in field of the urban investments. We also offer awareness raising and motivational training for city officials and employees of the city organizations and city companies. For the general public, we have created an application for mobile phones that can recognize tree species, monitor the condition of the trees, facilitate their care, but also calculate how the tree cools its surroundings in the hot summer days. For 3 years, we have also been organizing a nationwide contest of the best implemented adaptation measures called Adaptera Awards. We are running an extensive inspirational database of examples of the good practice. You will find great examples of implemented measures in 4 categories there: open landscape, build-up environment, residential buildings, and the buildings for work activities. You can find their stories of the wetlands and ponds built in the agricultural land, restored dirt roads and green belts in agricultural land, demonstration of changes in agriculture management, also examples of the good practice in rainwater management in residential areas. You can find there also restored parks in the cities, well-adapted office centers, also industrial halls cooled by the green facades, residential buildings using recycled grey water, also well climate adapted family houses or countryside cottages. The tool we have high hopes for and which should help cities to plan public spaces well is called TreeCheck Pro. This webinar will be dedicated to its presentation. It's an opportunity for city employees to get an overview how much cooling power the residential greenery brings in the different parts of the cities. At the same time, it will make it possible to calculate and compare different scenarios of public space revitalization projects. Specific calculations give the city administration data-based arguments. Based on them, it's possible to responsibly choose a solution with the required effect and gain public support for it. But my colleagues from Safe Trees company will tell you more about that. More about our project you can find also on the www.lifetreecheck.eu web pages. Therefore, on behalf of the Environmental Partnership Foundation, I would like to thank you for your attention, and I wish you a useful webinar today.
So, hello, ladies and gentlemen. Thank you for coming to our webinar. And after this introduction, my aim is to tell you something more about the background of the system of the TreeCheck Pro and about the possibilities of usage of the system. We created this system, as has been mentioned already, as part of international project, and it's result of more than 3 years of intensive work of scientific organizations and practical arborists and people from government of the cities. As my colleague already introduced, trees are part of the city environment, which is invaluable really, because it's very hard to be replaced. The benefits are very various and very individual, because each tree has its own position and the prevailing positive or negative influence on its surrounding is really unique. So we concentrated within our project to one of the main areas, which is the cooling effect of the vegetation areas, not only trees, but vegetation as general item. And the reason is that the development or the changes of temperature balance in the cities are strengthened by so-called urban heat island, which creates even worse, let's say, situation in regard of the feeling potential of the situation. So the influence of trees on cooling their surrounding, not only by evaporation, transpiration, but by the shadowing effect, is one of the strongest positive influences on which they have in cities. As you know very well, trees are dependent on water, and all their benefits, all their functions, physiological functions, are based on water balance. Trees are open, they need all the time take in new amounts of water, lead it through their stem and send it away through transpiration. This means that they need incredible amounts of water every day. Even small trees need something like 10 or 100 liters of water each day. The really grown specimen, large trees, need more than 1,000 liters every day to keep alive, to keep functioning. That means that the environment, the city environment, needs to support this need, and you know very well that this is one of the largest problems, that the management, the water management, when the water comes with precipitation and very quickly disappears from the area through sewage system, etc., is one of the, let's say, most important problems which now the development of large cities deals with. Trees have two main strategic behavior in this regard. Trees which are more of the pioneer species, like betula, willow, poplar, they tend to live on the surface or only in the surface area of the soil, and their water balance is based on taking in the water directly from the precipitation, so just the flat water. But there are trees which are more of the, let's say, consistent existence on the site, like oaks or beech trees or tilia trees, and they tend to develop not only the flat roots, but they try to reach to the ground level of the water and start to take in water from the lower levels, which is a very nice strategy if the system or the environment doesn't change too quickly. At the moment, we have we see problems with this water dynamics by both strategical parts of the trees. So in all tree species, because the changes in water balance are not just short term, but tend now to be really long term, and the change of the climate is very visible. Trees take the water through their own means, so the very small roots and their caps, but they use for the water management, for the water intake, as well cooperation with mycorrhizae, with the fungi. This is one of the factors which is quite often being overlooked in the city conditions, because we mustn't think only about the trees, but about their associates as well. If the mycorrhizae, the fungi, doesn't have adequate surrounding, adequate soil to develop, the tree doesn't have the chance to keep for long term. So the pH of the soil, the density of the soil, these are all factors which need to be, let's say, amended or adequate to support not only the tree, but the mycorrhizae, the associates as well. By the transport of the water, the tissues of the stem are being used, the xylem tissues. The transpiration flow is the path which the water takes within the tree, and it ends in the assimilation organs. Could be leaves, could be needles, or the scales, it doesn't matter, but the principle is still the same. The water column leads to the leaf, where the opening of the stoma makes the entry point, or the out point to the atmosphere. And all the regulation is very well done and very strict. More than 95% of efficiency of this process has been measured by trees, which is really amazing. But not only the transpiration, but evaporation. So the passive vaporing of the water is part of the process as well. For the tree to work, it needs to have adequate physiological status, so it needs to have adequate vitality. Vitality expresses the level of physiological stress of the tree, really. And the stress can have many connections. It can be colonization of the tree by pests and diseases, by wood destroying fungi. It can be limits to extend the root system in the area, or direct damage of the root system. And you know very well that trees in city environment face thousands of these problems continually. So if we start to calculate the positive benefits, we need to take in account the taxon specific items, the characteristics which the specific tree species have, but as well we need to take in account the individual characteristics, and from the point of the let's say level of stressing of the tree, the vitality is exactly the point which we need to assess. As has been already mentioned, the climate change is something which really takes very quick dynamics in last years. Within our country, large studies, and I'm sure that in all countries of Europe, these studies are taking place. What you see is a map which has been developed within a project which I will mention later on, which shows the zones of extremity for trees to grow. And you see that from the left upper corner down to the right down corner, the dynamics, this is partly being created on real data, which has been measured during the last decades. And the three last maps are, let's say, the projection, the model, what will look like in our country from the point of view of dynamics, from the point of view of the situation for trees in urban areas and in the urban or in the people inflicted countryside. So you see that if we plant trees and if you plan some trees to be retained for future, we need to count with completely different situation than it's now. And this is one of the very strong points which we need to address in cities, especially when we plan our new trees to be planted. And now to the real, let's say, know-how which stays or which created the model which we use in the TreeCheck Pro system. We decided to go through the way of quantifying the parameters which we speak about. So we try to calculate them on physical values and transfer them into monetary expression to have, let's say, as exact as possible outputs for decision makers. So we tried to not to use just estimates of coefficients or parameters because that can be strongly influenced by the people who do these estimates. Second point was that we tried to dig very deep to obtain as much, let's say, hard data for each step of the calculation as possible. We got the first, let's say, inspiration from the system iTree, which probably you may be familiar with, which is being used in United States. But we tried to bring this kind of thinking and this kind of calculation to very new and very much more precise level of implementation. And we didn't stop only at the point of telling what the situation is now, but we tried to join these outputs to other projects, which I'll show later on, which lead to not only to the thinking of retaining trees, but to advising how to do the new plantings and the changes in the environment as, let's say, as good as possible from the point of view of the climate change expected. So the analysis which the system TreeCheck Pro offers are being done in three layers, let's say in three levels of preciseness. These levels differ from the point of view of necessary data which are available, because we decided to offer our know-how not only to cities which have already created their greenery passport of dendrological analysis, but from all cities which have the interest of using this kind of philosophy. So the first level is based on analysis of the area using the, let's say, generally available orthophoto maps. We created a neural network and trained it to be able to distinguish between various kinds of surface based on orthophoto maps. The preciseness of the network is at the moment somewhere around 85%, so it's pretty exact. And in the areas where the analysis is being done, each square meter is being analyzed by this neural network, as a first level of entry data for the calculation. So of course this is not completely exact. On the other hand, if you need to analyze only part of your area, for example, if the area of interest is this plot, you still have the overview of the situation around the plot, so you know exactly where even privately owned plots or parts are around, so you can do your calculation very precisely from the point of each situation, each part of the city which is in the question. So we feel that this approach brings let's say new level of preciseness, even if the data is of course very basic for the first step. The second step of the analysis already demands to have data from the greenery passport and basic data about trees which grow on the area. So for the second step, we already need some info about the species structure, the sizes of the trees, and the sizes of exact, let's say, situation of grass areas, shrubs, etc. We feel that most of cities in EU already created this kind of overview for purposes of, let's say, the basic management of these areas. So we are pretty sure that this data can be made available for each large city in Europe. And the third level of the analysis is qualitative analysis, where we already demand the complete dendrological survey, where not only the sizes and tree species of the tree are being noted, but their vitality, their stability, and their tree care plan is defined. This is, of course, already pretty demanding level of information, but it makes possible not only to say something more about the contemporary status of the population, but to create something like vulnerability analysis and cost-benefit analysis for retaining the population. So all these data, we defined the quality of the data and the level of detail which we demand. In the Czech Republic, we have standards for each area. So we've got the standard approach to greenery passport, and the standard level or definition for the dendrological survey. This second standard is available in English as well, so we will send it to you as a link if you have interest to study it in detail. So I will now show you how the data looks like and what are the entry values for the calculation, and then my colleague will lead you through the user interface of the system. So as I told you before, the first level is the distinction or the analysis of the area using the neural network, which we call her RB. And this neural network just distinguishes between the green areas like grasses, shrubs, trees, and paved areas and water areas. And of course, areas which are not analyzed, so mostly there are other kinds of paved or brown fields or areas of that kind. So this first analysis makes possible to do, let's say, first level of calculation with not really too sophisticated models on behind. On the other hand, this can be done for all area of the city with no regard of ownership or accessibility of the plots. For the second level, as I told you before, we already need to know the dimensions of the tree. Even if we, for the, let's say, base or general dendrological survey, we use much larger amount of data. For our analysis here, we only need to know the height of the tree, the height of the crown, if possible, and the crown spread, so the basic, let's say, size which the tree shadows and which the tree just occupies from the area which is being analyzed. For each of these parameters, we have pretty strict definition how to measure it, what's the preciseness of the data which should be, let's say, collected. So, as I told you before, we will send you all these references if you want to implement it in your work. Yes, so these are the three basic parameters. Because each tree species and tree cultivar have a different architecture of the crown, we created 7 basic shapes which tree species or tree taxa can have, and they are part of our calculating models, like one of the general information which is connected with the tree species and tree cultivar. One of the main characteristics which defines how the shading effect and the transpiration of the dynamics of the transpiration of the tree in question looks like is so-called leaf area index, the delay. This was, I would say, largest part of the research which has been done within the project, and our colleagues from the Chaglope company were in charge of this analysis. We used published papers on this topic, and we clarified and made the data more precise by our own terrain work and measurements. So the leaf area index definition was one of the, let's say, most rigorous parts of the system which we went through. The lay expresses the density of leaves taken from the air, really. So the projection of the leaves on the flat areas. So you see very well that this delay differs not only between tree species but between individual trees as well. And the differences between individuals is best expressed by so-called vitality of the tree. I prepared for you a short video. I hope that you will hear the sound. Vitality, the vigor of the tree, characterizes the evaluated individual from the point of view of the dynamics of the course of its physiological functions. Within this diagnostic characteristic, we consider the tree as a living organism and evaluate the degree of its physiological stress. The included parameters result from the definition of the arboricultural standard evaluation of the condition of trees, available on a link below. Grade 1 is characterized by a densely leafed compact crown with no signs of peripheral dieback. The crown may be slightly fragmented on its periphery, but in principle it should be clearly visible that both the terminal and lateral shoots in the apex of the crown are formed from macroblasts. This is especially evident in the crowns of young trees in the winter period. Level 2 already shows stagnation of the growth, and the main sign is the manifesting of the dieback in the crown periphery, which is not caused by local shadowing by surrounding trees. In the winter period, significant fragmentation of the crown and a tendency to develop lateral shoots from brachyblasts is evident. Level 3 indicates the beginning of the crown's retreat, which usually manifests itself in the massive dieback of the top of the We classify trees with residual vitality in the level 4, in which more than 50% of the crown volume is dead. Level 5 includes completely dead individuals. In addition to the overall image of the crown, the following parameters serve as accompanying signs for determining the level of physiological vitality: extent and location of developed secondary shoots, number of years of needles, which also affect density of the foliage, defoliation, in non-deciduous conifers. Changes in leaf size, especially in the top part of the crown. Color changes of leaves and their necrosis, peripheral dieback, regardless on the causative agent. And the presence of symptoms of pests and diseases causing physiological weakening of the host. The vitality have the 5 degrees, which I explained to you right now, and these degrees are, let's say, the entry point to our calculation of the cooling effect or the dynamics of the transpiration and evaporation which each individual can offer. As another very large project which is within TreeCheck Pro, we started to download meteorological characteristics for all 4 partner countries, so Czech Republic, Poland, Slovak Republic and Hungary. More than 500 sites within these countries. Every day we download 3 times per day the characteristics which you see there. So if we calculate the efficiency of tree or vegetation area in certain context, we take in account the exact meteorological characteristics from the last 365 days. So the calculation is very precise, not just generic situation, let's say from this part of the globe, but the real situation from the last year. This makes possible the calculation or the analysis, which we will show you later on, where by analyzing trees in different parts of the country or different parts of Europe, you will get completely different data, different dynamics of the or efficiency of the tree. So mostly this is based on this kind of analysis. And of course, if we speak about trees in certain context, we need to take in account when that if the tree disappear, they are disappearing for really long periods. So the decision-making process, whether to allow these trees to be removed or not, must be really rigid one, and must be taken in account all the connective issues. So the trees are creating the living area for several generations of people, and we must be aware of that. For this reason, the analysis of what the effect of these trees on changes within the microclimate are is something which is at the moment not being used in the Czech Republic, for example, at all. And the value calculation of the tree deals only with the replaceability of the individual, which is not fully able to express the dynamics that if we remove the trees the next 20, 30, 40 years, we will not be able to replace their value by any technical means. So what my colleague will show you later on, this kind of analysis makes possible to really weight the pros and cons of each project, of each reconstruction or development project in the city, and to really start to discuss not only the short-term but the long-term dynamics as well. For the connective projects, I would show you just shortly one part or one service which we developed recently just for the conditions of Czech Republic. But on the other hand, if this rings a bell for you, we are able to provide you with the know-how how we created this system, and probably you could implement it as well. This is a tool which we use for our dendrological surveys. You can check it on the webpage www.checktrees.com. And within this system, we created a tool to choose properly the new trees to be planted in each areas. As I showed you before, we consider the new planted trees to be working not for now, but for future, so for next 40, 60, 100 years. So we mustn't analyze the area not only from the past, because the climate change is coming and is strongly influencing the growing conditions for the new trees. So we tried to do do the analysis for hard data for the at the moment existing trees, and to create a system which advises or defines each tree species by a score which we call the adaptation efficiency of each tree species and each cultivar in that particular area. The area is defined either by the generic, let's say, color within the map, or it can be defined by each, let's say, each raster within the country. So you can either analyze the efficiency of the tree species which you plan to start planting in your cities from the generically available data or from the hard data of your area. So this is just the system which advises which tree species have the chance to survive the change conditions due to the climate change in each area of the country. So this is just a short note as an appendix of the system which we are presenting to you at the moment. I hope I made clear what the, let's say, input data are and how the background of the calculation looks like. If you have any questions at the end of this session, you will have the chance to discuss on that. But at the moment, I will give word to my colleague and she will show you what the system itself looks like and what the user interface is prepared for you. Thank you.
At the beginning of my lecture, first, I would like to mention the data sources that the software is capable to work with. In the second part, then, we would look at the login to software. Then I will show you individual procedures in calculating the cooling function, the cooling power of greenery. And finally, I have prepared a short case study for you to better understand how the software works. So now we are going to talk briefly about data sources. Part of the data is acquired automatically thanks to continuous collection of meteorological data, as my colleague said before me, and thanks to characterization of subject locality, as is, for example, elevation, etc. And another necessary input parameter for the software is current greenery of the locality of or site. So if the city has no available data, then analysis is based on aerial scans of the locality, which is then evaluated as of artificial intelligence. And then the output is very simple calculations. But if the city has more detailed data, like, for example, green passport and detailed dendrological survey of trees, then the data are very, very detailed. The outputs are very detailed. In the Czech Republic, currently data can be imported from the portal Stromy pod kontrolou, and the possibility of importing of the data is now manual. But if you have your own database of trees, then after contacting us, we can certainly help you to work with data, to work with your greenery, and work it further. So now we'll just move to TreeCheck EU, the website. The basic information or basic input for using the software is registration at the website TreeCheck.eu. Registration is very simple. It's actually standard procedure like in any other application. You can register in two ways. You can register as an organization, and within the organization you can register individual users, but you can also register as an individual. So if we now look at the detail how the registration looks like, we can fill in a country, like for example, Czech Republic or Polska, Slovak Republic, Hungarian. So just fill the first column, organization name. I will put here Save Trees organization, what number of the organization, for example, contact email address, postal address, contact phone number to you, and then name of the person, email address on you, once again, and password, which should have at least 6 characters long. You should also fill the consents due to, for example, GDPR and other. So just tick all the consents, and then you can register. Moreover, if you register, you can then modify your consents after that. So now I'm going back to my presentation, and I will just show you once again how the registration looks like. So once again, click on register. Fill in then all characteristics like country, organization name, what number of your organization, contact email address on you, postal address, contact phone number, name of the person, email address on you, then password, and consents. Within the scope of the user background, consents then can be modified. So another part of my presentation is calculation of the cooling function. It works in a simple way. In a very simple way, I will just go back to software web page TreeCheck.eu. So this is how the software interface looks like. Now I am in Brno city. I'll just get enough zooming to some place and locality in Brno, and click in the map. And we see a table where you can calculate tree cooling power, shrub cooling power, or lawn cooling power. I just want to calculate now, for example, tree cooling power. So click on an icon, and we see just one more table where we see species, crown spread, and vitality, which are defined. And here you can see the pop-up menu where you can choose the taxon which you want. For example, I want to calculate tree cooling power for Acer negundo. Crown spread can be, for example, 20 meters. Vitality can be significantly reduced. And here you can see altitude. Altitude is adjusted automatically, so you cannot fill in this characteristic. And now I just click on calculate, and we see that the cooling performance for last year was 65 megawatt hours. It's a physical unit, so just look at it. And this is how it works. So now I just go back to my presentation and just look once again how it works. So just get enough, zoom in into map, and choose the option you want. Fill in the table. Here I just want to calculate tree cooling power for Tilia cordata, and other characteristics will stay as they are. And we see here that the cooling power for Tilia cordata was, for last year, was 27 megawatt hours. Now we will move to higher altitudes. For example, to city Vrbno pod Pradjedem in Jeseniki mountain. And then just once again, get enough, zoom in into map, click on fictional tree, click on calculate tree cooling power, choose the same taxon. So the Tilia cordata and other characteristics will stay as they are. And here we see that the altitude will adjust automatically. So once again, click on calculate. And here we see that the cooling performance for last year was only 9 megawatt hours. It is because of higher altitudes and lower cooling power of the same species here. Okay. So if we look at the map, it's nice to see here how the cooling function for the same species is changing with the change in altitude. So, for example, here in Brno, Tilia cordata cooling power for this species was 27 megawatt hours. For the same taxon in Prague, it was 20 megawatt hours. And for the Tilia growing in Vrbno pod Pradjedem, it was 9 megawatt hours. Another part of my presentation is cooling power heat map. So I will just go back to software web page. I will move now to Ostrava city. Get enough zoom into, for example, this place. And tick the cooling power heat map. And now we see the colored squares, the colored tiles, which expressed an individual trees here. So I will just tick here the legend, cooling power heat map. And it means that if we wanted to look at the legend, the colors show that the more that colors go into purple color, the cooling effect is higher. In the Ostrava city, it is based on available inventories, which was made in this part of Czech Republic, and passports that were made in this locality. So now I will just go back to my presentation and show you once again how it works. So just get enough zoom in, tick the option cooling power heat map, and we see these squares or tiles, colored squares, which expressed individual trees. We can now we can move to Stromy pod kontrolou portal, where we can see it on the given specific tree inventory which was done in this place. The color dots expressed individual trees. So just look how the basic looks like and go back to website. Do we see that individual trees? So now once again, here are individual trees, and in these parties where it blends, we'll see that there is a much higher cooling effect. So once more, we can see a legend. The colors show that the more the colors goes to purple, the cooling effect is higher. And the last function which I want to show you is a general calculation of the cooling function and planning function. Again, this is based on a map background. So once again, I will just go to website TreeCheck. And just get enough zoom in some place once again. Now we want to create a plan. So tick here this option. Maybe just get enough, get enough zooming. And we see some squares. You can choose up to 10 squares. The calculation, is just, I will tick here, for example, 3 squares, and click on an option save. And the calculation itself takes some time. So now I'll just go back to my presentation, and I will show you here how it works. So get enough zoom into some place which we want. Tick create plan and choose the squares we want. I choose here 3 squares and click on an icon save. Yes, and here we see the results. We see here some initial state of these 3 squares. We see here amount of trees, amount of shrubs, lawns, water surfaces, paved surfaces, and other. But we see here the financial, the cooling function is expressed in physical units, here in megawatt hours and in financial costs. We can rename our new plan. It's better to rename it because when we have a lot of new plans, it's just better to know which plan was that. So I just put here the name Ostrava Poruba, for example, click on an icon save. We can show it in map just to see where were our squares. And we can also add scenario. Add scenario means that we can remove or add some elements because of, for example, investment plan or changes that are in the city. So we can remove, I just here remove 100 square meters of trees, for example, 200 square meters of lawns, 200 square meters of paved surface, and add, we see here abbreviation SC and LC. It means small crown trees, like for example, Carpinus betulus or genera Malus or Prunus, Acer campestre, and other taxons. And LC abbreviation means large crown trees that are, for example, Tilia, Quercus, genera like Populus, Pseudoplatanus, maple, sorry. So here we just put 10 small crown trees, 50 square meters of shrubs, and small water surface. We can reset our scenario, but then we should fill the characteristics to the table once again. We can save it. And then click on an icon, calculate. And now we see here how the financial, how the cooling function looks like now, but we can see, moreover, we can see how the cooling function looks like after 3 years, after 5 years, and after 20 years. Here we can see in Czech the financial costs in Czech crowns, but if you logged in like a Polish people or a Polish organization, you will see the financial costs were expressed in zloty, and you will see the abbreviation ZWO. So if, so if someone from, for example, Hungary were logged in, you will see here forints, and Slovak people will see euros. So we see the financial cost here and cooling function expressed in megawatt hours. And here I just add one more scenario. I removed here only 500 square meters of paved surface and add 50 large crown trees, 100 square meters of shrubs, 200 square meters of lawns, and 500 square meters of water surface. And here we can again see how it looks like after 3 years, after 5 years, and after 20 years. The second scenario is 10% higher after 20 years than the initial state here, the current state. The scenario number 1, the resulting value of cooling power and financial cost is quite lower compared to the original calculation to the current state. More accurately, it is lower by 16% after 20 years. So this scenario is better for us. So in such a way, we can create, we can modify, we can vary our scenarios and choose the best, most feasible option. So thank you very much for your attention. And if you have any question, please do not hesitate to ask. Thank you.